So we're looking at 1.1 in pre-calculus, where you can use a graphing calculator Oops. Did not realize I did that. I'll make sure I'm using that. There we go. Graphing calculator. I'm just going to assume that you can use a table, or you know already this when you plug in the square root of 0, you get 0. When you plug in 1 for x, you get the square root of 1 is 1. I'm going to jump to 4 because I know the square root of 4 is 2. And we have this function like this. Now the only difference when you add 2 on the outside, so if you plug in, like if you make a table, you plug in 0 for x, well the square root of 0 is 0 plus 2, you get 2. So that's the value for f of x. Now I hope you're already familiar with function notation. So I can do the same thing when I plug in 1 for x. When I plug in 4 for x, square root of 4 is 2, add 2 to it, you get 4. And again, you can use a graphing calculator to see these answers. Next one, really the same idea, except we are subtracting 2. And so what happens is these are different types of shifts. Alright, whoops, trying to scroll down. So letter B is a function that is shifted up 2. The fancy math term that we use is a translation. You probably saw that in Algebra 2. So then what happens when we add inside? Well, what you could do, and I've taught it this way before, is I tell my students to write an equation of like x plus 2 equal to 0, and when you subtract 2 over, you get x equals negative 2. So if you were trying to make a table of values, that's the number you want to start with. And the reason why you want to start with that is when you plug in negative 2, you have to add 2 first, and you get 0, then square root 0, and you get 0. So this might help you understand why this is a shift, just like the other plus 1 and minus 1s, except now it's left 2. And instead of the other function being 4, we want to go to 2. 2 plus 2 is 4. Square root of 4 is 2. And we see our graph that looks like this. Same premise on this one. Let me change colors just to liven this up a little bit. Maybe a little bit bolder of a color. Is I've taught it where I tell students to take what's inside the radical, set it equal to 0, so when you add 2 over, this is actually shifted right 2. And the reason why you want to shift it right 2 is because if you plug in 2 for x, minus 2 is 0, and then the square root of 0 is 0. And so 6 would be that third point that I've been messing with. Because 6 minus 2 is 4, the square root of 4 is 2. So this is a shift right 2. Then, in this function, when you have a negative in front, I would again encourage you to try some different values, like making a table. Well, if you plug in 0, it has no effect. That negative has no effect. It's still 0, 0. But if you plug in 1 for x, the square root of 1 is 1, but then it's negative of that. And this might help you actually see why this is a reflection, or a flip is kind of the lame word we use, over the x-axis. And then in letter G, we're doing a combination of transformations. That's what these are called. Now, the important thing to realize, the 0, 0 is still the same, excuse me. But if you were to plug in positive 1, you'd have negative 1 right here, and you cannot square root negative 1. So that's why you would plug in negative values for x, like negative 1. So it's a negative of negative 1, which is positive 1. Square root of 1 is 1, times 2 is 2. All right. Same thing as you'd want to plug in negative 4, and the square root of negative 4 is, well, I said that wrong. Negative of negative 4 is positive 4. The square root of 4 is 2, times 2 is 4. So negative 4, 4. So our graph looks something like this. Please ignore this dot. I accidentally put that there. So there's two transformations here. I'm going to call the first one a reflection over the y-axis, but then a dilation or a stretch of 2, or sometimes we say a factor of 2. Stretch by a factor of 2. And this, again, algebra 2 might be coming back to you right now. The best way to explain this one then is the same thing I mentioned earlier, where setting what's inside the radical equal to 0, and might help you understand why as you add 2 over and then divide by -1, that the first number you want to plug in is -2. Because if you look at it, you have negative of -2, which is positive 2, minus 2 is 0. But then from there, you might want to say, oh, well, this negative, just like we had a negative right here, was a y-axis reflection, so you probably want to try values to the left of that, like -3. So positive 3 minus 2 is 1. Hopefully that makes sense. And same thing is the next value you'd want to try is probably -5. Nope, -6, because the negative of -6 is positive 6 minus 2 is 4, and the square root of 4, that's a -6, is 2. So our graph looks like this, and again, please ignore that extra dot I accidentally put right there. Now the order that you write this actually matters. You want to write the reflection first. So it's a y-axis reflection, and then shifted left 2. Alright, and the order matters because if you said left 2 and then a y-axis reflection, it actually would be the wrong graph. If you notice, this problem is very similar to it. The only difference, if I do my work the same way, is it's subtracting 2 over first then. And I hope you recognize then that this is still a y-axis reflection because of this negative, but then shifted right 2. So it's reflected over the y-axis again, but this time it's right 2. Okay, so if you've been using a calculator, you might not have, and I haven't been using a calculator, I'm just working through it. So what you've probably noticed that I've been doing is I've been looking at this value, what's under the radical, and I've been playing with that the most, like setting that equal to 0, and that's going to tell me my starting point if you were to make a table. So what you'd want to do is subtract 1 over and then divide by -1 to get your starting point at x equals 1. So this time we rename the function g. So if I plug in 1, well, -1 plus 1 is 0. The square root of 0 is 0 times 2 is still 0 minus 3 is -3. So 1, -3 is my starting point on this problem. So because we have a negative right here, let me change colors to emphasize a negative right here, that's my y-axis reflection. So it wouldn't make any sense to try numbers to the right of x equals 1. So I'm going to go back and try numbers to the left, like 0. Well, -0 plus 1 is 1, the square root of 1 is 1, times 2 is 2, minus 3. 2 minus 3 is -1. So 0, -1 is a point. Now this is where you have to be a good critical thinker and think about how we know the next perfect square root is 4. So you'd want to try a value like 3, -3, excuse me, because negative of -3 is positive 3 plus 1 is 4. The square root of 4 is 2 times 2 is 4 minus 3 is 1. And if I'm going too fast on that, feel free to try it on your own and see if you get the same answer. Pause the video, etc., etc. Yeah, so that is what our graph would look like. And then if we state the changes, basically what it boils down to is this is the first thing that happens. If you notice, the next thing so this is the first transformation. The second transformation, maybe I'll write them in pink, is the dilation, the stretch of 2. The third thing, I'm just trying to squeeze it all in this tiny screen right here, is the shifts. And we always say our shifts based off of 0, 0. So it's shifted right 1 and down 3. And you can kind of figure that out because of what's under the radical. Now I know it's plus under, but it's still right because of the negative right here. And the minus 3 is your indicator that's down 3. So some students that figure this out pretty quickly can look at this one and say, okay, well, there's no y-axis reflection. So if you did the same trick that I've been showing you, you set it equal to 0 and add 1 to the right, it's definitely shifted right 1. Because it's a positive x value. I'm also going to make the conjecture it shifted up 3 because of the plus on the outside. And what I should have said first is this negative in front, which is a reflection over which axis? The x-axis. So instead of being an upwards square root function, it's a downward shifted right 1, up 3. And the graph looks something like this. Feel free to use a table to get these answers. So let's write down everything that we know about this. Actually, I'm going to stop the video here and I'm going to make a second one to finish these notes.